Okay, so this is college algebra. We're going to talk about several ideas. We're going to talk about first the slope formula, which indicates the steepness of the slope of the line with a numeric value. And to illustrate this, we're going to look at every possible configuration of a line. It could go over and up like that. It could go over and down like that. It could remain flat. Okay, that's supposed to be flat, or it could be straight up and down like that. Okay, and we're going to call the slope, the number for the slope. I'm going to fix this a little bit. I want this to be straight up and down. Okay, so these are the configurations, and we're going to use a number m to represent the slope. And if the slope is going up, then we know that that slope m is positive or greater than 0. If the slope is dropping downward, then our slope m is less than 0. If it's a flat line like this, then it's not sloping in either direction, so it doesn't go greater than or less than 0, it stays at 0. But here we have a case where we're not even indicating an over direction. As we go over, we continue to go up, and that's all we do. So we say the slope is undefined here because we can't really configure it. Okay, so this is going to allow us to identify the slope formula. We're going to say that if x1, y1, and x2, y2 okay, so if I can identify these 2 points on the line, and x1 is not equal to x2. Okay, so here's the idea. We can calculate that exact value for the slope, how steep it is, kind of slope it is, by setting y2 minus y1 over x2 minus x1. Okay, that's also the rise, change in y over the run, which is the change in x. So change in y, that's what delta y means, over change in x delta x. Okay, so essentially we'll use this first one because we'll be given points here. And if x1 equals x2, we got to clear up this case. Then we're in this situation where the slope is undefined. Okay. So we're going to put this to use. So I'm going to come over here and say, find the slope. Okay, so if I've got a line that contains the points 2, 1, and 3, 4. Okay, so we're just going to tap into this calculation right here. So then m is equal to, well, here's my 0.2. So this is 0.1, 0.2. So there's my y2. So I'm going to take 4 minus y1, divide that by 3 minus 2. Okay, so that's 3 over 1. So that says that for every 3 we rise, we move over 1. So my slope is 3. Another example, let's say this time it's going to contain the points 5, 3, and 5, negative 2. Okay, so if I try and plug this into the slope formula, I'm going to get m equals negative 2 minus 3 over 5 minus 5. So something's wrong here, right? That equals negative 5 over 0, and we can't divide by 0. But look, we broke the rule here. We said over here that if x1 equals x2, so this is 0.1, 0.2, and the x values are equal, well, that means that we have undefined slope. And that's why we end up dividing by 0. So if we miss that the x1 and x2 are the same, we're going to catch it here when we try and create the slope, because you can't divide by 0, so this is an undefined slope. Okay, so this line is going to be one of these vertical lines. This line's got a positive slope where m is greater than 0, so it's going to be slanted like that. Okay, so that's how we calculate the slope if we're given 2 points on a line. So now we're actually going to create the equation of a line. New page on here. Okay. All right, so this is called the equation of a line. And it defines all of the points on the line. So every point is embedded in this equation. So there's one way that we can look at it called the point slope form. And this says if x1, y1 is a point on a line, slope m. So if I know some point on the line and I know its slope, then y minus y1 is equal to m times the quantity x minus x1 is the point slope equation of the line. Okay. So we want to use this. It's a little too small. All right, there we go. So let's do a little exercise with this. Let's say that we'll say that we have a line slope of 2 through the point 35. Okay, so we're going to create this point slope form. So I'm going to take, oh, okay, so I'm going to take my formula here for the point slope form, and I'm just going to plug these parts in. So here's my point. So there's my x1, y1, and then there's my slope m. So I know that y is y minus y1, y minus 5 is equal to my slope 2 times the quantity x minus x1, which is 3. So x minus 3. Okay, so we're going to leave it in this form, but we're going to see later that if I solve this for y, we'll generate a new form of an equation for a line.
これだけ俺結構これはあれしたね。作ったね。作ったね。待って、これ入ってる、これ入ってるよ。
I'm going to go ahead and mute everybody here. Okay. Let's do another one. We're going to do an example where we're going to go with a slope of -1 through -1/2, -2. Okay, so for this one, we've got the point with a fraction in it. So I'm going to take and use my formula here. Y minus -2 is going to become y plus 2. Then my slope is -1, so that's going to be -1 times x minus -1/2 is going to become x plus 1/2. Okay, so if we know a slope, the key here is that if we know a slope and a point that's part of the line, we can generate an equation for the entire line by plugging those known values into our point slope form. Okay, so far we've looked at the slope formula, the point slope form, and now we're going to look at another form. Okay, I think I'm going to move over to a different app that I know a little better, so I'm going to scrap that. Okay, so now we're going to look at the slope-intercept form. Okay, so given a slope m, and y-intercept b, we think of the y-intercept as a coordinate point, it's going to be 0b. This just is where it touches the y-axis, so x is 0. And the equation is simply y equals mx plus b. Okay, so note that the slope is the coefficient of x, and the y-intercept is the constant when I'm solved for y. So all we have to do to find this is to solve for y. So let's look at an example. So let's say we have the equation. Three x plus y minus 5 equals 0. Okay, so our job is going to be to rewrite this into slope-intercept form, this form we've just learned up here. Okay, and then we're actually going to graph the line as well. Okay, so this equation is not in slope-intercept form simply because it's not solved for y. So all I have to do is move all my terms that aren't y over to the other side and isolate y by itself. So I'm going to do that over here. I've got 3x plus y minus 5 equals 0. So if I add 5 and subtract 3x from both sides, it takes no time at all to produce my slope-intercept form. Not only that, I know by this form that my slope, m equals -3. My y-intercept is 5, or the point coordinate 0, 5. Okay, so that gives me enough to know, clean that up, what I need to know to graph it. Okay. All right. So their next job is to graph the line. So we've done this. If I want to graph the line, let's see if I can get a straight point here. Okay, it's gonna have to do. All right. So I know that I've got a coordinate point of 0, 5. So at 0, 1, 2, 3, 4, 5, I've got the y-intercept. And then I also know my slope is -3. So remember, that's a rise, -3 over a run of 1. So I'm going to go down 3 because that's negative and over 1. So I'm up here at 5. So if I go 1, 2, 3, and then over down 3 and over 1, puts me right here. If I go down 3 more and over 1 again, puts me here. So essentially, I've got the line made, and it looks like this. And if I had to draw it manually, I wouldn't do nearly as good a job. So it looks something like that. So this is the line y equals -3x plus 5. Okay. Let's look at another form of a line. So this is called the general form of a line, and we actually just saw it. Okay, and it looks like ax plus by plus c equals 0. A and b can't both be 0. Okay. A, b, and c are real numbers. So let's say that we want to graph a line by intercepts. Okay, I'm going to go with a white background. Okay, remember our form was ax plus by plus c equals 0. So we're going to graph, let's do 6x minus 2y minus 12 equals 0. We're going to do this by plotting intercepts. Okay, so all I have to do is create a little small table. And in one case, I'm going to lock x at 0. And in the other case, I'm going to lock y at 0. So if x is 0, then 6 times x, which is 0, minus 2y minus 12 has to equal 0. So that's 0. So negative 2y minus 12 equals 0. So negative 2y equals 12. So y must equal -6. So the coordinate for y that goes with the coordinate 0 for x, we found to be -6. I'm going to do the same thing with y. So if y equals 0, then 6 times x minus 2 times 0. See what's happening here? The term goes away if it has the 0 for the variable. Okay, so 6x minus 12 equals 0. Add the 12. So if 6x equals 12, of course, x is going to be 2. Okay, so when we use 0 for y in our equation, we get back for x must be a 2. Okay, so now we've got all the information we need to graph because these are the intercepts. Okay, so I haven't used this for a while, so I'm trying to get. All right, I'm just going to freehand the rest. So if I've got 1, 2, 3, 4. Okay, so there's -5, there's 5. -6. Okay, so I just need to plot these 2 points, 0, -6. And then 2, 0. And then our line is the line through these 2 points here. That's hard. Okay, so this is the line 6x minus 2y minus 12 equals 0. All right, I am trying to record this and I'll save it and put it up. So if I'm going too fast, you can watch the recording and pause it. So we've looked at the slope formula. We've looked at the point slope form. We've looked at the slope intercept form. And then the general form. Okay, remember slope formula is m equals y2 minus y1 over x2 minus x1. Point slope form we said is y minus y1 equals m times quantity x minus x1. So here you need 2 points, x1, y1, and x2, y2. Here you need the slope m and a point x1, y1. Slope intercept form we said is y equals mx plus b. Here you need to be given the slope m and the y-intercept b or 0b. And then general form was ax plus by plus c equals 0. And here we learned that if you set one of these to 0, you can find the other one and get the 2 intercepts. So what I want to cover now is special cases like horizontal or vertical lines. Okay, so horizontal line is going to reduce to y equals a for some constant a. So for example, let's graph y equals -2. Okay, so if this is my coordinate system, Then it says, this says no matter what x is, y equals -2. So if x is -3, then y is -2. If x is 0, y is still -2. If x is 4, y is -2. So no matter what, we maintain an output for y of -2. So that creates this horizontal line through -2 of y equals -2. Okay, so this is our horizontal. Notice in a horizontal line that the x variable does not show up in the equation. So let's contrast that with vertical line. We're going to graph so in a vertical line is x equals b or some constant b. So let's graph x equals 3. Okay, so in this case, no matter what y is, x is locked in at 3. So 3 goes with the y of 2, 3 goes with the y of 0, 3 goes with the y of -2. So no matter what my y is, x is always 3. And that creates the vertical line. Okay. I'll get started on parallel and perpendicular lines. And then I'll probably give you an assignment after this. So. Parallel lines have the same slope. So we might be given a task like this. And so for example, we're going to find the line through -2, 2. And parallel to 2x minus 3y minus 7 equals 0. Okay, so we know that this line is going to have the same slope. As 2x minus 3y minus 7 equals 0. Solve for y. Okay, so if I take this and solve for y, I'm going to know the slope I need for a parallel line that goes through negative 2, 2. Okay, so let's go ahead and solve this for y. So I'm going to subtract the 2x, add the 7. So I get negative 3y is equal to negative 2x plus 7. Okay. Now all I need is the slope. So now I'm going to divide by negative 3 everywhere. And that gives me y equals negative 2 over negative 3 becomes positive 2/3 x minus 7/3. Okay, so if I'm finding a line that's through this point and parallel to this line, then since we found this line's slope to be 2/3, the parallel line through this point has to also have the slope of 2/3. So now I know I'm working with a slope of 2/3, and I'm going through the point negative 2, 2. So that means I can use point slope form to construct the line. Okay, remember point slope says y minus y1 equals m times x minus x1. Here's my m, and here's my x1, y1. Thus, y minus 2 equals slope 2/3 times x minus negative 2, so that becomes x plus 2. And now let's take this and we know this is parallel to 2x minus 3y minus 7 equals 0. Now let's rewrite our line. Y minus 2 equals 2/3 x plus 2, quantity x plus 2, into general form. Okay, so that way it looks like this one. All right, well, that's easy enough to do. I just have to basically clear the fractions. So if I multiply through by a 3, so we'll take 3 times y minus 2 is equal to 3 times 2/3 x plus 2. So I get 3y minus 6 equals, and then those 3's are just going to cancel. That becomes 2 times the quantity x plus 2. So I get 3y minus 6. Distributing the 2, I've got 2x plus 4. And now I just want to set this equal to 0. So I'm going to put the 0 on the left-hand side. I'm going to subtract the 3y and add the 6. Okay, so I get 0 over here. 2x minus 3y plus 2. Okay, so notice the only difference between these two in general form is the constant. This is minus 7 and this is plus 10. Okay, I'm going to go ahead and send you off to the MyLab module 4. And you'll want to do 17 through, I believe, 34. Okay. So yeah, we're going to break just a little early, but that gives you time to go ahead and get started on your MyLab homework assignment. There are also videos attached to the prior to each question set. There is a video that you can watch for extra support there. So essentially what you're going to end up doing is a little bit of everything that we've done today. Okay, so I'm going to go ahead and stop my share here on the video. That's my plan anyway. There we go.